Hello, and thank you for joining me today. My name is Larry Price. Today's topic covers remote monitoring of SCADA networks using the ASE2000 V2 test set. Present-day challenges include the COVID-19 pandemic. This is having a huge impact on operations team members and troubleshooters in SCADA today. With social distancing requirements, restricted access to facilities, and mandatory shelter-in-place orders. In addition, large geographical areas of responsibility need to be managed and monitored. SCADA technicians and engineers need the ability to remotely assess and identify problems as they occur on critical SCADA infrastructure. For outage responses, downtime is minimized with the ability to monitor and test from remote locations without a need to be on site. With ASE2000 V2 test set, benefits include the ability to remotely access private networks through VPN services. You can identify problem devices or error conditions before mobilization of personnel to locations. The test set supports capturing and logging of both bit and byte exchanges across SCADA network segments. This information can be logged and saved. These files can then be shared amongst team members for collaboration during analysis, troubleshooting, and/or when archiving. ASE2000 can operate as a master or RTU outstation. This provides the flexibility to test both upstream and downstream. The test set also provides third-party support for import of Wireshark packet capture files and text file capture imports. Multiple bit and byte protocols are supported. To see if we support your needs, please review our capabilities on www.ase-systems.com under our protocols section. For communication options, connectivity is established via serial RS-232 or Ethernet communications. The ASE2000 test set supports synchronous or bit protocol, asynchronous or byte protocol, and network protocols. Serial RS-232 communication is provided by the BCOM USB hardware device provided by Applied Systems Engineering or through native ports on a PC. It is important to understand that legacy bit protocols cannot be supported via standard serial ports on PCs today. They don't provide the necessary signaling required for communication. The PC connection to the USB BCOM device is achieved via standard USB cable. Both USB 1.1 and 2.0 is supported. Network communication uses standard network ports on a PC. When evaluating master stations, the test set utilizes RTU mode of operation. The test set can simulate toggle point changes in real time, and users can generate and change quality flags and additional parameters to evaluate master processing of this information. Data exchanges can be captured and saved via the local session or user-specified capture file. Files can be exported, shared, or imported for later analysis and review. For RTU testing, master mode is utilized in the ASE2000 test set. Scans can be generated to retrieve point information such as binary, analog, counter input information, or output statuses. Options available are protocol specific and dependent on user selections made in the ASE2000 test set. Log files can be generated to capture specific events in the test set over longer testing durations. End users have the ability to define binary and analog event criteria for this logging. Connection with serial devices for monitoring requires the ASE monitoring cable. This cable is placed in line between DTE and DCE devices and is a passive connection. Bidirectional traffic is visible through the test set. On Ethernet networks, the PC running ASE2000 test set must be on the same network segment as the RTU or master station under test. Monitoring of Ethernet communications requires the usage of a network hub, Ethernet tap, or with a network switch capable of providing a mirrored port. Connections are made with standard network cables. Here is an illustration of the three different methods of monitoring communications on SCADA networks using a PC loaded with the ASE2000 version 2 test set. The top line shows a connection on the serial interface of the PC connected to a serial adapter and RS485 communication loop connected to RTUs. This will only support serial byte protocols, as bit protocols require specialized signaling for proper protocol communications. The middle connection shows a connection made with the ASE-provided BCOM USB device, which provides RS-232 signaling via 2 ports that supports standard and legacy bit and byte protocols. 4 connections are made. 2 are dedicated for the DCE and DTE connections, and 2 connections to the BCOM USB serial ports. On the lower line is illustrated a connection via the network or RJ45 interface on the PC. The PC can connect either directly with a local area network or through private network to a switch with a mirrored port, an Ethernet tap, or a hub. Regardless of the option utilized, this is a passive connection and can only be used to monitor communications. Scans, controls, or any active exchanges are not permitted in this mode of operation. A note on accessories and the options for monitoring communications. Network hubs, also known as Ethernet repeaters, can be utilized for communications capture, but are not abundant in the supply chain. Network taps, also known as Ethernet taps, are commercially available and abundant in today's market. Typical Ethernet taps consist of 3 ports, 1 dedicated for DCE, 1 dedicated for DTE, and 1 for passive monitoring. These devices are plug and play, typically intuitively labeled, and require no configuration or management by end users. Layer 3 switches or mirrored port switches are common and may or may not be present in your substation or environment. If not available, a portable mirrored port capable switch may be used. Port mirroring requires configuration of the switch to actively monitor connections. Before deploying or utilizing a mirrored port switch for communication testing, check with your IT department location for support and any security policies that may be relevant. In some cases, the equipment may be already on location and simply require activation of the mirrored port by a network administrator. There are 2 options on your screen now that show means of remotely accessing SCADA networks using Ethernet connection. In option A, the test set end users can access private networks through a VPN firewall using an IPsec client. IP security or IPsec protocol provides both authentication and encryption of the data transferred between client and server via TCP/IP communication. This is one of the most common methods of remotely accessing networks. Option B shows a PC using a remote desktop application connection via SSL or secure socket layer, or TLS or transport layer security. The basic process consists of a client contacting a server, requesting a secure connection. The server will challenge the client and pass or fail the request once the challenge response is received. If authentication occurs, information from end to end between the client and server is encapsulated and encrypted as data is exchanged. Various encryption methods can be used for the communication session between this client and server. In addition, there are multiple remote desktop applications commercially available for use. Another means of remote connection can be established using virtual serial emulator software. This software creates virtual COM ports on a PC that may otherwise not have a physical serial port. The virtual ports connect with a remote device via TCP/IP connection with serial data encapsulated. Once the destination device receives the serial data, which in this case is a terminal server, it is processed and transferred via physical serial port to the outstations or master stations. These connections act no different than physical connections. Port settings such as baud rate, parity, and flow control are adjustable on the virtual COM port. Connectivity occurs using TCP/IP with a terminal server. Serial information is encapsulated in a TCP/IP frame and transferred to the terminal server's targeted port. Serial data is processed to and from a terminal server connected to a field-side device on the network with a PC running ASE2000. I hope these examples and explanation provide you with an understanding of remotely accessing, monitoring, and troubleshooting your SCADA network. If you have questions on our product capabilities or would like to follow up, please contact us at www.ase-systems.com, and on our website we have protocol support information listed as well as contact information. Thank you for your time.